Today, lesson 32B, similar figures and scale factors. As I mentioned a minute ago, we've been working a lot on proportional relationships and the idea of solving proportions. And we're going to use those ideas to extend it out to similar figures. And then from that, talk about something called a scale factor. So let's go ahead and get started here. Background knowledge. Remember, how to solve a proportion. If we have a proportion like that, we would multiply both sides by 15. And then from there, we need to figure out what 4/9 times 15 over 1 is. Most of us multiply straight across and then reduce from there. But that would turn into, after we reduce and convert it back to a mixed number, 6 2/3. Or this one, where we'd have to use that upside down property because we need the variable to be on top. We've solved, at this point, hundreds of proportions like this. So to refresh your memory, we multiply both sides by 5, and then at that point, most of you take 5 over 1 and multiply it by 11 over 3, and then we convert that, since it's improper, to a mixed number. So W is 18 1/3. So we have to remember how to deal with proportions in order to talk about what we're about to discuss today. So similar figures, and I believe at this point you have some things you need to fill in your notes. Similar figures. They are figures that have the same size, or excuse me, the same shape, but not the same size. Figures that have the same shape, but not the same size. And the way that I've always thought about this is it's like one is a blown up version of the other, or one is a shrunken down version of the other. So for example, if I have this rectangle, and that is in your notes, where the 100 is the base, the 50 is the height. So far this year I've had you find the area and perimeter of lots of rectangles like that. Well, if I take that rectangle and blow it up twice as big, as far as the sides go, where now the base is 200 and the height is 100, these two are similar figures. The bigger one, the base and height are twice as big as they are of the smaller one. And if I sort of put that in a table, and I would like you to copy that table down. If I write the base and height for each one, so as you're doing that, the base and height here are from that rectangle, and the base and height here are from this rectangle, and just in case you didn't see that. And if we take and think of this table in terms of maybe X and Y, and find the ratios like we've been doing a lot of, and what that would lead us to is this. We have 50 over 100, which simplifies to 1/2, and I have 100 over 200, and that simplifies to 1/2. Just figuring out our Y over X ratios like we've done lots of times, we can see that they both simplify to 1/2. That proves to us that this is a proportional relationship, just tying it to things that we've been working on. Okay. So, the sides, and I've already said this twice, the sides of the large rectangle on the right are twice as big as the sides on the small rectangle on the left. That's one way of looking at it. Another way of looking at this is this, and as most of you realize, there's something to fill in your notes there. The other way of looking at it is like this. The sides of the small rectangle on the left are half as big as the sides of the large rectangle on the right. All right. So let's continue on here. Scale factor. The scale factor, and this is another spot where you need to fill something in your notes. The scale factor is the ratio. We've seen that term ratio many, many times so far this year. The ratio of any two corresponding lengths in two similar figures. Now, I already hinted at this when we first looked at that table, but if we write down our ratios, if I want to write down the ratios of the small rectangle to the sides of the large rectangle, I have 100 over 200. Now, where did I get that? I got that over that. In other words, it was something that we already looked at right here. And that simplifies to 1/2. And you should be writing this down. Or, if I look at the ratio of this to this, in other words, what I did when I first had talked about the table here, I would have this ratio, 50 over 100, but of course that also simplifies to 1/2. So that 1/2 is extremely important. So those ratios lead us to the scale factor. The scale factor of the small rectangle on the left to the large rectangle on the right is 1/2, or 1:2. Because if I compare the two, the small rectangle is half as big as the large rectangle. Or if we look at it in terms of the base, for every 1 unit of the base of the small rectangle, the unit is twice as big as far as the base goes on the larger rectangle. Same thing for the height. Okay, so when we go from a little or smaller shape to a larger shape, that's called an enlargement. We usually, and this part I know is not in your notes, we usually compare shapes in the same direction that we read, from left to right. So if the shape gets bigger from left to right, that's called an enlargement, like this. If the shape gets smaller from left to right, that's called a reduction because it's getting smaller. All right, so let's move on here. This is our official number 1. What we're trying to do here is we're trying to figure out what this side is right here so that this is a proportional relationship. That's what we're trying to figure out. There are lots of ways of doing that. Let me say that one more time. We're trying to figure out what this side is right here so that we have a proportional relationship. And I'm stating right off the bat that the two rectangles are similar to each other. So one way of doing that is by using a proportion. So what I'm going to do is I'm going to start by listing sides of the small rectangle over the sides of the large rectangle. So I'm going to take this side right here. That's a side on the small rectangle. What side on the large rectangle lines up with that side? Just say it. 72. It's 72. Are we all okay with that? Yeah. We want to pick sides that line up. Now remember, to finish off my proportion here, I'm putting the sides from my small rectangle on top. So that means this 7 right here needs to go on top. And of course, I'm trying to figure out what that side is right there to create a proportional relationship. Now, we need to solve the proportion. So from here, of course, we should use the upside down property. So that means we need to flip both fractions because I need the variable to be on top. Now, my advice all along has been this. If you can reduce this fraction or that ratio, I would do that before you even start. This is one of the reasons why some of you get bogged down with such large numbers. Simplify that ratio if you can. Now, if you don't want to, that's fine, but you're going to have much, much larger numbers than you need to have. Okay? So regardless of what you do, though, at this point, you need to multiply both sides by 7 so that we have the variable by itself. And I'm going to let you finish that proportion. So you could just multiply straight across, but some of you are not even bothering at times to look to see if you could reduce that fraction right there. So you would have to agree that this is much, much easier to deal with. 7 over 1 times 8 over 2 is much, much easier to deal with than 7 over 1 times 72 over 18. You would have to admit that. But no matter what you did, you should end up with x equals 28. So what that means is that when this side is 28, we have a proportional relationship. Now, how would I know that? I would know that because if I were to do a table I'm going to skip the table because I'm almost out of room. 18 over 72 will be the same thing as 7 over 28. In fact, they both reduce down to 1/4, which means that the smaller rectangle is 1/4 as big as the other one. So let me go ahead and get caught up here. Exactly what I just talked about. In this one, I just left it unreduced. Once again, to talk about 504 divided by 18 is much, much more difficult than 56 divided by 2. But regardless, the missing side is 28. Now, there are other ways that you could have done your proportion. So listen up here. And I'd like you to write these down somewhere. You could also do 7 over x equals 18 over 72. You could use that proportion. That's one possibility. You could also go in reverse order. If you wanted to do large on top, instead, you could do x over 7 equals 72 over 18. And if you stuck with the large on top, sides of the large rectangle, you could also have 72 over 18 equals x over 7. So we have this as the original proportion that we used. We could also use this one, or this one, or this one. Any of those would give us a missing side of 28. All right, so let's continue on here. So now we know that that missing side right here is 28. We know that. But we want to find now the scale factor. So how do we find the scale factor? Well, I already kind of talked about that. Let's write our ratios of small rectangle to large rectangle. So let's start with 18 over 72. Could I get everybody to please reduce that? Okay, so that reduces to 1 over 4. Now, remember, this side right here is no longer x, it's 28 because we just found it. So I'm going to take those numbers right here, 7 over 28, and I need to do that just to make sure we have a proportional relationship. So 7 over 28, by the way, is also 1/4. So that gives us our scale factor. So the scale factor of the small rectangle on the left to the large rectangle on the right is 1 over 4 or 1:4. And I would like everybody to find the missing side with number 2. Set up your proportion and solve. So to find the missing side, what we are trying to do is we're trying to figure out what this side is right here so that we have a proportional relationship. If you say it's 5, for example, guess what? We don't have a proportional relationship. Let me prove it to you. Let's pretend like you think that side is 5. So if I check my ratios, 5 over 24, the question is that equivalent to 6 over 18? This reduces to 1/3. This does not reduce. They're not equivalent, so it can't be 5. We're trying to figure out what that side has to be so that we do have a proportional relationship. And today we're using proportions to help us out with that. So I'm going to go with the sides of the small rectangle over the sides of the large rectangle. So I'm going with x over 24 for my first ratio, this over this. And I'm going to set that equal to the other ratio following the same sides of small over sides of large. And that would be 6 over 18. I still hold with my recommendation that if you can reduce that, you should. Did anybody reduce that fraction before they started? Yes. Well, it's 1/3. So instead of solving this proportion, you could instead solve this. Why can I do that? Because 6/18 is equivalent to 1/3. And you have to admit that this is much easier to deal with than what you're about to have to deal with if you didn't do that. I'm just giving you tips in my advice what you should do. And I know many of you don't even check, so I'm going to leave it just like that. And when I solve it like that by multiplying both sides by 24, I get 144 over 18, which simplifies to 8. So what that means is that when this side is 8, we have a proportional relationship. And that's very important because now we need to find the scale factor. So I'm going to see if you can figure out the scale factor. Go ahead. All right. So the ratios that I already used, the first ratio I'm going to use is 8 over 24. Now, where did I get 8 over 24? Well, we just found that this side is 8, so I'm using that ratio of small rectangle to large rectangle right there. 8 over 24 reduces to 1/3. We use the other one to check. Once again, small over large. That also reduces to 1/3. This is not the first time that we've taken ratios and simplified them. We've been doing it for 2 weeks now when we're checking for proportional relationships. As it turns out, that is the scale factor right there. That means that the bigger rectangle is 3 times as big as the small one, or the small one is 1/3 as big as the larger one. So our scale factor is 1/3. All the rest of the problems, this is what we're doing. We're finding the missing side, and we're going to use that to help us figure out what the scale factor is. All right, any questions on number 2? If you set up your proportions correctly, the scale factor is kind of done for you. All right, everybody try. Number 3. Several ways of solving or setting up your proportion. I'm going large triangle over small triangle. The side, if I'm going to put 12 on top, I have to put the side that lines up with it. And that's the problem with 2 or 3 of you right now. You're not even paying attention to what you're doing. You're just randomly picking numbers. Since I'm going large over small, I got the 12 from the large and the side that lines up with it on the small. That's where I got that. The rest of my proportion follows still large over small. So the large side that I haven't used is 8. The side on the small triangle that lines up with that is x. There is one possible proportion that you could use. You could also use 10 over 12 equals x over 8, which is what we get after we use the upside down property anyway. And then from there, I need to multiply both sides by 8. You could have, of course, reduced that before you even started, 5 over 6. But I'm going to multiply both sides by 8 and then convert to a mixed number, so I get 6 2/3. So once again, this is the 3rd time I've talked about this. What that means is that when this side is 6 2/3, we have a proportional relationship. That's what that means. The second thing we were supposed to do is we were supposed to find the scale factor, now I'm telling you, of the large triangle to the small triangle. Some of you wrote 5:6. I know where you got that. You got that because you said, all right, he said it comes from the reduction of that fraction. Well, that's fine. But is the 5, is that from the large or the small triangle? Say that again, please. Small. This is from the large. We're supposed to list the large part first. So it should be 6 over 5 or 6:5. That's what the scale factor should be because we're comparing the larger to the smaller. And you have to pay attention to what part is being listed there. And I can get that by going 12 over 10 or 8 over 6 2/3. They both reduce to 6 over 5. So let's use that same sort of thinking to now solve number 4. Find the missing side so that we have a proportional relationship, and then find the scale factor. One possible proportion would be 12 over 10 equals 15 over x. I'm going with sides of the large over the sides of the small. If I'm going to set it up that way, I have to use the upside down property, multiply both sides by 15. And of course, you could have reduced the 10 over 12 before you even started. But regardless of that, we get 12 and 1/2 for x. So what that means is this. When this side is 12 and 1/2, we have a proportional relationship. Now, scale factor. Scale factor from large to small, and I went from large to small again. It ends up being exactly the same thing as the last one. It should be 6 over 5 or 6:5, and I can get it by either taking 12 over 10 or 15 over the 12 and 1/2. And when I do that, they both simplify to 6 over 5. All right, I'd like everybody to solve number 5. Number 5 is an extension, and this is where we're headed with this, taking a word problem, thinking about it in terms of a picture, and using similar, in this case, similar triangles. If we know the shadow length of a tree and a person is standing right next to the tree and they're 6 feet tall and their shadow's 5 feet, if we think about this as similar triangles, like we've just worked on, we can easily figure out approximately how tall the tree is. Go ahead and give it a shot. One possible proportion you could use would be the height of the tree over the height of the person equals the shadow of the tree over the shadow of the person. And then we just have a simple proportion to solve. You could reduce the 25 over 5, but some of you are not even bothering to check that one more time. But that's okay. You can still get to what you need. It's just going to take a little bit more work. But we end up with a tree that is approximately 30 feet tall. Now, where is all of this headed? Well, all of this is headed by taking figures, blowing them up or shrinking them, and then comparing their side lengths, the perimeter of them, and the area of them. And this is one of the reasons why I've been making you do that next problems every week. And then from that, we're going to end up finding the scale factor, which basically works exactly like the problems that we dealt with today. All right, we are finished.